All right, let's get serious. So, this is the Computer Programming University where learning is always fun, as it should be, and it's only fitting that I also discuss some techniques that can help you to learn faster and more effectively. I teach you guys a lot of things that can definitely have a major positive impact on your lives, from programming and technology and things like that. But one thing that I have not really taught is learning techniques. I certainly make it easier for you guys to learn in terms of the way that I present the material, the entertainment side of it, the simplicity and the way I break things down, the analogies that I use. And I hear a lot of the positive feedback from you guys, and that's awesome. But I want to also teach you some techniques. So we're going to talk today about the Feynman technique. So before we get into the Feynman technique, which we'll be getting into shortly, sorry, wow, the beauty of doing a live stream, random coughs. Anyway, sorry about that. So one thing you have to consider when you're thinking about the process of learning is there's a lot of factors involved that I'm not going to get too deep into. Try to focus on the fundamentals. So one of the key fundamentals is retention. And essentially when we say retention, more specifically, we're referring to the forging of new memories, right? And not just the forging of new memories, but of long-term memories. You have short-term memory, you have long-term memory, right? I think a lot of you, like most of us, struggle with a bias to the short term, right? You can sit here and watch one of my videos and have a good time, and I break things down and it's simple, and it's kind of like, I get it. And then a day later, a week later, what do you really remember? What do you really understand? What was the actual benefit long term of the new information? A lot of times it may not be what you expect, and that's because, again, bias towards the short term. So what I mean by that is we are obviously organic. We're not digital, right? When you store something in memory in a computer, it simply stays there, right? It's an instantaneous transfer of information and storage in a particular medium, right? That's not how we work. We are organic. So it's kind of, I guess, to make an analogy, imagine a plant. For those of you who are into plants, you will understand, but I think others just understanding of I mean, you've seen a plant before. I'm sure you can understand these basic ideas. So the idea of having a house plant that is sort of leaned this way, right? Now, the way a lot of us try to learn things is in a very binary format, and again, bias to the short term. So short term is, let's take this branch and let's push it upright, right? That's the short term, really quick and easy, binary, right? It was sideways, now it's upright. Very simple, very black and white, right? Unfortunately, that's a short term solution, right? You remove your hand from the plant, from holding it upright, and pretty much the result is going to be that it's going to fall right back, right? That doesn't work. Now, if you were to push something against the branch and leave it there for perhaps a few weeks, then when you remove that item, you might find that it's mostly upright, or maybe it's perfectly upright. But either way, you would have a greater retention of the intended effect of your actions, right? The intended effect of your action is to upright the branch, right? And the way you got that was through the repetition, through the consistency. And that's the way that things work in the organic world as opposed to the binary world. And you are an organic creature. Your brain is an organic instrument. So simply sitting there and, I got my Python reference, great book, by the way. And I'm going to sit here and I'm going to read something randomly out of the back of this. So it says the time module, time.clock, returns the CPU time or real time since the start of the process or since the first call to clock, parenthesis, parenthesis. Precision and semantics are platform dependent, returns seconds expressed on a floating point number, useful for benchmarking and timing alternative code solution sections. So that's the short term. That's the binary. I just read it, put it in my brain. Now ask me what I just read. Kind of vague. I have a basic idea. I've actually used the module before, so that helps. But as I'm even sitting here, more and more of that memories are already starting to fade. That's the short term, right? So a key element is going to be retention. And you think about practice makes perfect, right? The more you practice something, the better you get at it, right? So that's a key concept as well. Now, the Feynman technique is more specific, more precise in its execution, and I'll get into the details of how you can utilize that. But I just want you to understand one of the major things, right? If I can't recall the memories, right? I can't recall what it is that I've read, then my comprehension of it is going to be compromised, right? How can I comprehend something that I lack the tools? If you guys know what that reference is from, comment below. Anyway, I need to have the information in my brain to be able to comprehend something. I can't comprehend something that I'm not recalling the information or details about it, right? So obviously that's a huge thing. So here's a Feynman technique and how you can help to sort of forge those memories through repetition, through keeping that pressure on that branch over a long period of time to where the end result is now the branch, upright branch being Python. You want to learn Python, right? And you watch my video and you walk away. You watch another video, you walk away, right? How do we get to the watch the video, use the Feynman technique, right? And in the end, retain the knowledge. So essentially it starts with a clean sheet of paper. So get yourself a piece of paper. So first of all, you expose yourself to the information you're trying to acquire, right? So you watch the video, you read the book, whatever it is, right? So you put that stuff in your brain. And just to further illustrate something I didn't cover and what we're fighting against, it's important that you understand what you're fighting against in order to be the most successful at winning the battle that you're trying to fight, right? So I already touched on it when I talked about short term, right? You push against the branch, move away, falls back down, right? So what's happening in your brain is you have this, I would call it an input medium. So that is the construct at which your brain is able to access new information. So imagine new information is stored in this medium, this construct, right? And what the problem is, what's happening is most of us in today's world, we have information overload, right? Your brain can't hold all the information that's it's receiving, right? So a lot of that information sort of vanishes, right? It's there for a very short time and it vanishes. Just like how someone explains something to you that may be complex and you kind of feel like you understand, and then they ask you to explain and you can't explain because a lot of the data points are vanishing, right? And this is the initial phase of what's required to really understand something and have it long term. The next phase is for that information to be transferred to your long-term memory, right? You got to get the information into your long-term memory storage in your brain, right? If information is being lost from the input funnel, we'll call it the funnel, right? If it's being lost in that phase, it's never going to make it to long term, right? You got to be able to survive the input phase in order to make it to the long term storage phase, right? So you've got to deal with the information leakage at the input phase, right? And I'm just speaking in general terms, keeping it very simplistic so that you can understand, right? So when I talk about the Feynman technique, we're talking about addressing the information leakage that's happening here, and in order to get the information that you want to retain long term into the long term phase, right? So in order to do that, so you have the input phase, you read something, you watch a video, whatever it is, new information. You get your piece of paper out, right? Going to go old school. Technology, can be a lot your friend, but it can also be the opposite. Use technology as a tool for what it is best for, but also understand and realize that there are times when you will need to distance yourself from the technology, right? Don't let technology be everything for you, right? You can use the technology, for example, as a way to acquire new information, right? Whether it's sound, video, whatever it is. Even reading a book on your tablet, right? Like I do. That's great. It's wonderful. But don't live on the technology. For example, Feynman technique gets you off of the technology. You can acquire the information from the technology, but use something more organic to retain this organic information. Once again, you're trying to store the information in your organic brain, right? So it's one thing to have a digital input, but ultimately your long-term storage is not digital, it is organic, right? So embrace some organic techniques which speak more to your organic brain. So pen and paper, right? Write on the top of the paper what the subject matter is that you're trying to study. Python loops, polymorphism, right? Unsupervised versus supervised learning for machine learning, right? Whatever it is that you're trying to understand, right? You want to study meta classes. Title on top of the page, take it back to school, right? There's some things from school that actually are good. There's many things. I'm speaking to the fact that there's a lot of important information that you don't attain from school, whether it's elementary, junior high, high school, or college. There's definitely some issues with traditional education system, but one of the things that are good that we learn from school are these types of techniques. And I'm actually speaking old school. I don't know, maybe things are different now. I just consider that. I know you're using laptops and things like that, but when I went to school, we used pen and paper, right? So write your title. Try to write like you're doing an assignment in school about whatever it is you're trying to learn, whatever it is you just learned, right? Whatever you just put in your input, your digital input, right? Polymorphism is a concept in computer science where, right, I don't remember, right? So what you do is you write out to the best of your ability whatever it is that you're trying to learn, and there'll be points where things that you miss, things that you're not clear on. Identify those things, red marks, circles, whatever. Identify what things that you struggled with. Then you want to, so that's phase one. Phase two, revisit the information. So go back to the source of the information. It could be another source, doesn't matter. But the bottom line is you want to pick out things that you weren't sure about, and you want to go back to input again. So input phase number two, focusing on areas that you are having difficulty with. So you don't remember this particular concept or this kind of thing, you were vague here, revisit that information, right? Come back to the paper. Try to fill in those blanks, fill in the stuff that you're missing, and keep refining the process until you can fully explain whatever it is that you have recently learned. whatever new information that you've acquired. Then, as the final phase, what you want to do is you want to do something that I am well known for, and something that I do all the time, although not specifically for the Feynman technique, because my techniques came before my knowledge of the Feynman technique. It was just something that it was a goal of mine, and something that sort of came naturally to me. So I try to simplify concepts. That's one of the key things why people subscribe to my channels and love my videos, is I'll take a complex concept and simplify it. So the final phase of the Feynman technique basically is what I do, right? Take the information and simplify it. You've got a lot of buzzwords, and it's very wordy, your explanation is, right? So try to simplify it to where you can attain potentially the widest audience where they can understand what you're saying. So for example, simplify it to the point where a child can understand it, right? If a child can understand the complex concept that you are trying to learn through your teaching them this information, then you have succeeded in your execution of the Feynman technique. That's a demonstration that you have ultimately comprehended the information, and therefore also have done the required tasks to pass the input information into your long-term storage. So now you've gone from just hearing information and just having information be temporarily in your brain or your mind, to having it be in long-term. So now I've not only been exposed to this information, but I comprehend this information. I know this information. Polymorphism. I know what it is, and I can explain it to you because I understand it. I can give you complete detail, and I can break it down, not just repeating what was in the textbook. I can say it in my own words and simplify it to the point where almost anyone can understand it. That is a true demonstration of understanding and comprehension. And that is the goal of the Feynman technique. Now, if this has been helpful to you, go ahead and click on the like button. Definitely subscribe. But don't do that unless you're going to also click on the notification bell, because that's the only way you're going to get notified of awesome videos right here on this channel. The Computer Programming University, where learning is always fun, as it should be, and it is, right here in the Computer Programming University. Thanks for watching, and until the next episode, salute, arrivederci, hasta luego. Where is the stop button? Oh, let me go back to my knowledge acquisition. I'm going to learn everything. I'm gonna know everything. Oh, this technique, that's not part of the deal. The video title says Feynman technique, which is what I just taught you. So as far as this technique of absorbing knowledge from a book through my headphones like this, I'm sorry. Gotta keep some secrets, at least. Don't you think?